Hey folks, welcome to this episode of the Application Security Podcast. This is Chris Romeo, CEO of Security Journey. I'm also joined by Robert. Hey Robert.
Hey Chris, yeah, it's Robert Hurlbut and Threat Modeling Architect. Good to be here.
All right, so the topic for today is something called SEMGREP. And we're going to figure out what that is because I think I know what it is, but I'm not 100% sure. But first we have to understand our guest, where he comes from. And so our guest is Drew Dennison. And Drew, we're going to jump right into what is your security origin story? How did you get started in this crazy, crazy world of security?
Hey, Chris, thanks so much for having me on the show. Let's see, probably like most of you, I was kind of the designated computer troubleshooter growing up in my family's home. We had dial-up internet and I don't know, I ended up going to our local library and getting a lot of Windows XP books and trying to just configure and learn a little bit about the Active Directory and kind of all the IT side of things. And then at some point I stumbled on Hacking Exposed, which is a classic book. And so read through that in probably freshman year of high school, I think. And then what really I think got my interest in security though was reading some of the cryptography books. I read Bruce Schneier's Applied Cryptography, and there was a great book about the history of cryptography. And so kind of just going into college, I was really interested in basically math and crypto, with a little bit of security just from some of those earlier kind of IT, like configure your network, turn off all your remote desktop, tunnels and everything like that. So then, went to MIT for computer science, and Ron Rivest was one of the choices for freshman advisor. And I was like, oh man, childhood dream come true. I have to pick Ron. And Ron was just the coolest, nicest, smartest guy, and really didn't want to talk about encryption. He was much more interested in if I was getting enough food at the cafeteria. And I was just like, no, come on, we gotta talk about security. So ended up doing major in computer science with a concentration in encryption and applied sort of more practical security, stack smashing attacks and stuff. And one of my favorite classes was 6857, which was the introduction to cryptography class that Ron Rivest taught. And I remember, I want to say it was a spring semester class, and I think literally 2 weeks before the class started, the NSA had declassified some old papers, these kind of almost serial killer looking notes handwritten from John Nash. And he sent them in back in the 50s and was like, hey, I designed this unbreakable encryption machine. I think it was actually a physical machine, almost like an Enigma. Would you guys be interested in this? And I think, someone must have FOIA requested it, and they dumped all that out. But anyways, our first assignment was to go through and break this unbreakable encryption. And it was obviously there were flaws in it. So I think we did the statistical analysis. Ron had Rivest made a Python implementation of it as best as he could follow kind of John's hand-drawn notes. And, we got to go through, and there was actually some real, I was actually just looking up on the system right before this podcast, and there was really interesting things that, John Nash did have, which was you should basically have the security of your encryption based on a parameter about how hard it is to make things, computationally difficult. And so you could go through and say I want a longer key, right? And of course, modern crypto, we think of that you want a 256-bit key or a 512-bit, or a 1024, and you can kind of tune that computational difficulty rather than just scrambling, letters, if you will. So that was just a fun thing that really got me hooked. And then after that, I graduated and went to one of the Silicon Valley companies, Palantir, which was a great first job. Was doing consulting work there. Probably wouldn't join Palantir now, maybe, but anyways, I was assigned to doing a lot of incident response work. So got to go see large banks and retailers. Think the largest retailers like Home Depot, Target, those kind of size companies, or big banks in the U.S. and Europe, and would kind of go either post breach or towards the end of my time there, we were working on some cybersecurity insurance products where I was I had this hunch that basically the cleaner your network is, or kind of the IT hygiene or health, would tell you your probability of getting hacked. And so rather than having the standard compliance questionnaires, do you have a firewall, do you have antivirus, do you encrypt data at rest, we're well, we've got to be able to technically assess some of these things. Could we just get metrics? And then we were partnering with an insurance company. They were going to do statistical analysis if those hypotheses were correct. And so I worked there for about 4 years. mix of basically being a software engineer and the security incident response work. Worked as part of a team doing that. And then my old college roommate, who had gone off to work at the Department of Defense doing more offensive hacking, and I'd been chatting, and we just were like, there's got to be something we can do in security together. Do you want to start a company? And so he was considering getting his PhD, and ultimately we started R2C together. And so now I'm the founder and CTO of R2C, but I've always just wanted to kind of bring more like software engineering practices to automate more and more of security.
That's very cool. I almost wish we could play a game of, like, since you're someone who studied crypto extensively, where you say something and then we have to guess whether it's actually crypto related or whether it's something you completely made up off the top of your head. But we didn't have time to prep for that. Our producers were busy doing something else, but maybe in the future as well. So the topic we want to cover today is this idea of this tool. And I'm trying to think, you spoke about this tool, I think, recently at a conference, is how I saw even that this thing existed. And I looked up on the GitHub page and I went SemGrep, because I certainly know what grep is. And I'm like, wait, this is like a static application, kind of static scanning kind of solution that has some of the fundamentals of grep in it. And so there's my terrible, probably, description of what this tool is and what it actually does. But from your perspective, what is SemGrep?
Sure. So SemGrep is an open source tool that our company's been working on. The history of the project's actually about 10 years old. So somebody we hired last year, Yoann Patalou, who's this French PhD, static analysis genius, and was Facebook's first static analysis hire. Was working on a tool called sgrep at the time at Facebook. And I think, kind of reading between the lines, this must have been the early era. He was like employee number 100 or 200 or something like along those lines. This was definitely the like move fast, break things. There was no types. There was nothing like that. So Facebook was having lots of bugs and lots of errors. And so the first tool he built was this, basically a way to let you, just search for code patterns, because he probably started with grep, but was like, grep's not very precise. It's designed for strings. If I want to look for like this specific function call, and so, he told me at Facebook, they wrote about 1,000 different rules over time. And they would say like, hey, this method's deprecated. Go please use this other method over here, and that way, if like a brand new hire or an intern started, they could kind of get some basic program analysis running on every single commit on Facebook. And then I know Yoann hired Julian, who's the creator of Hack, which obviously adds types to PHP. And so, Facebook went definitely down the type language support, and they built other products like Flow and stuff. But Yoann worked at Facebook for a while and open sourced sgrep as part of a larger program analysis package. And then he kind of retired, did career change, something. We went to Italy and was working on a couple different books, and was just kind of thinking about what was next for him when we got in touch with him. And he's like, oh, that's pretty cool what you guys are doing. And so now he's working full time with us out of Italy. And, we've kind of expanded the original sgrep core from just one language or two languages, like for PHP and some C and C++, to what are the modern programming languages people want to use: Python, JavaScript, TypeScript, Go, Java, and we're adding more. Like, it's pretty straightforward to add things, but fundamentally what it's doing is it's letting you kind of just express, hey, I want to look for this pattern in my code, and I'm happy to show a demo. But it's like, if you're going to reach for grep to search, like, is the word password anywhere hard coded? It's oftentimes you can be a lot more precise with a tool like SemGrep, where you can say, is password, is something passed to the password keyword argument or something like that. So yeah, it's pretty easy to use. It's all open source. We've been using it ourselves, and what we've found kind of anecdotally is you can write a new pattern about 10 to 50 times faster than you could go write like a Flake8 plugin or an ESLint plugin or some other more traditional, actual static analysis framework. And so what it lets us do, like one pattern I was just working on last week was, I didn't actually realize this until I caught a bug in my own code, but in Python code, if you just use exit as a keyword, it works most of the time because it's an interpreter built in. But really what you want to do if you're going to ever do some performance optimizations or something is use sys.exit, right? It's just a really simple bug. It's not even a security bug, but I was like, I can just go in 5 minutes, wrote the little pattern, and now it's checked into our open source repository of these rules, and it's just like anyone now can be like, oh, that's a small bug. And so I think a really interesting application of that is application security and checking for misconfiguration or insecure frameworks, things like that.
So there's a list. So there's a rule base then, or pattern base that's part of the project. So if I'm somebody new that's coming to this, I can take advantage of all the existing rules that you've written for Python or Java or one of the other supported languages. I don't have to figure out all those patterns myself on day one, right?
Correct. Yeah, there's about 200 rules we have out there right now that we've sort of vetted and written, and we're getting other rules from a couple different people. One like from the Node.js scan tool, he contributed about 50 rules, and so we're just over time, building up this repository that's just open source for ways for people to say, I'm an expert in, let's say the way you do database calls in Django. Here's 5 rules that just kind of catch common bugs that I've seen. And so that's been really nice to just sort of share these patterns.
So is this the replacement is this designed to be a tool that causes me to say I don't need traditional commercial static application security testing tools?
It certainly could trend that way. I like to think of it somewhere in the middle between grep and like a full-blown commercial tool. Or even an open source, SaaS tool. I think the areas that we probably don't have right now is anything that involves sort of state tracking, or if you want to do like really deep taint analysis, a tool like Coverity, for example, is going to have 10 years of really great PhD research that's been done in that. But one of our hypotheses is that it's sort of a trade-off. If you want to go do like whole program analysis, it's often very slow, and you end up looking for kind of, I would argue, like language type bugs of like, oh, this Java variable is null here, and you're going to dereference it, and that's going to be a bug, and that's cool, but it's often prone to false positives. And I think where SemGrep really shines is when you have like a framework, like, okay, we're going to use this library to do all of our encryption. I want to write something that says nobody should be importing SHA-1 or MD5 or any like bouncy castle or something like that, because I know that like you should just use the NACL strongbox encrypt function, and so just I want to audit all my code base of where people are doing authentication, but it's happening kind of outside the trusted path. So we'll see. I mean, I think as we get more features, like we're working on some basic taint stuff, and I could see it kind of moving in that space, but right now I think it's probably more of like the 80-20 rule. Get 80% of the value of a full SaaS product with hopefully less than 20% of the effort.
Yeah, and I got to imagine it's pretty quick from a performance perspective.
We are targeting 100,000 SLOC per second, so that's about half the speed of grep. Certainly never going to be as fast as they like rip grep or any of those tools, because like you're not able to just do like ASCII or Unix character matching and regex engines. Like you are actually parsing things into a full abstract tree, but all the core work is done in OCaml, so it gets compiled to native code.
So you said it was 100,000 lines of code per second. That was the metric.
That's our target for just single pattern. I want to look for someone imported this function or something like that. It should be fast, and like I think the use case that like we've been using internally is either as a pre-commit hook, which has been like worked quite well, or a GitHub action or a Circle CI where you're like, hey, as long as it finishes in less than like 3 or 4 minutes, totally fine. Happy to block the build because that's going to be faster than my test suite.
Yeah.
And I think that is like an order of magnitude better than I've never personally used like Fortify or Checkmarks or some of these like more heavyweight things, but anecdotally I've heard those will typically run for hours, and then you'll get a report and you have to go through and kind of triage that, and it's not like in line with when the developer's thinking about that bit of code.
Yeah, I mean that's the whole DevOps approach to the world, though, right? Is like what you're doing with SemGrep is the way things have to be to live in a pipeline. Like you can't tell me that I got to run my SaaS tool and I need 2 days. Like, oh, we just pushed 300 versions of code in that 2 days, and we created a backlog of scan time of 12 years, all in that 2-day period, right? And so you've really got you guys are your team is and I'm sure there's a lot more people behind this as well. But the concept of doing this in a high rate of speed is certainly the way to go. So you mentioned pipelines as one use case. Like you can include this in your Circle CI build pipeline, GitHub Actions. Now, I'd have to configure my own GitHub action. It's not something that's part of GitHub today.
We have an action on the GitHub Marketplace that is actually pretty nice. So you can just go to like install it and you paste in 3 lines of YAML into the GitHub action workflow if you've ever done something like that.
Okay.
And it's really nice. And it's like, we've improved it a lot in the last couple of weeks. So like a new version is coming out soon. But what it'll actually do is it will run the tool twice. First one on like kind of before it applies the patch, and then applies the patch and then runs it again and then diffs the results. So the nice thing is rather than showing like thousands of findings, which you're like, I'm not even a developer, I don't even want to think about some other bug in a different part of the code base. It just is going to show you the findings that are in that 15 lines of code or whatever you submitted as part of that pull request, which I think is really nice because then you're like, oh yeah, or like maybe I disagree with the tool and I want to archive it and just be like, add that to the whitelist file. Great. But if it's something I've done, I'm like, oh, actually you're right, I forgot to close that file descriptor. Or I can have a nice message that's like, hey, please don't use a float field for money. Like you should use a decimal field because it doesn't have floating point errors, stuff like that. So
yeah, no, I think that's a neat way to approach it. I think that's one of the things I've already said this like 3 times in the last couple of podcasts, but my 2022 words I'm putting together are developer empathy. Like as security people, That's what we struggle with is putting ourselves into the mind of the developer. And what you're doing there is you're creating a GitHub action that's smart because it's a developer first function in that, of course, the developer doesn't care about the 10,000 other lines of code. They care about what they just committed, the changes to what happened there. And so that's brilliant to give them just what happened because they're not going to be able to say, that doesn't apply to me. Well, yeah, it does because it was your code that changed. It was your change that made this thing pop and go on. And so, yeah, I think it's a really, really neat way. So GitHub Action, pipelines. What other use cases are people running this? Are developers running this on in their local build environment, their local development machine to check things pre-check-in?
I run it as a pre-commit hook, and so I just use the pre-commit framework, and I have a bunch of other things, including like Black and Prettier and MyPy and all your like style and formatters and things like that. And then I just added this as a pre-commit hook as well. So that's worked pretty well. I think the other like major use cases we've gotten, one is security teams looking to do like asset inventory of their code. So they want to go through and say, show me, I've got 15 or 20 different repositories. I'm going to write 3 lines of a semgrep check that looks for someone who's importing like a auth-z authorization decorator that says admin only. Show me across all my code bases, what are the routes that have any sort of authorization, or maybe more interestingly, which ones don't have any authorization at all. And then they can go through that and kind of do that auditing kind of at a code inventory level. Another use case we've gotten some interest from has been the security like research community. And so these have been either like professor, grad students, or often like bug bounty hunter types. And so one thing that we've done, this part's not open source, but we've built out, and this probably goes more towards our commercial offering, we've built out a giant MapReduce framework, our platform using AWS, and we can scale up to like 5,000x parallelization. And so what that lets us do is say, I want to run this pattern across 1 million JavaScript repos, or the top 10,000 Python packages, and just that takes about 2 minutes or something for us to go through and scan that volume of code, because we go in the background and spin up thousands of these cheap spot instance executors, and it costs us like 10 or 20 bucks to kind of go do a scan like that. And what that lets us do is 2 things. One is we think about writing more and more rules into this open source rules repository. We can kind of tune them on real code and be like, oh yeah, actually here's this edge case we had to go fix. But it also lets people say, I'm going to write this vulnerability thing and almost do a variant analysis across the entire ecosystem of open source projects, and then go submit bugs. And so we're just starting to talk with a couple of security researchers. One of the guys is like, I think, number 5 on HackerOne for JavaScript vulnerabilities, and he's been pretty enthusiastic. And I think we're at the stage right now with semgrep where we've gotten it, so I'd say like an alpha product, and we're just kind of looking for the teams and the people who are like, this is really cool, I want to shape it exactly to my use case. And so I'm really focused on reducing friction and just making sure it stays performant and is easy to use.
So are you it sounds like you're mostly code agnostic then. You're not, because you're running outside of any IDE, out of any environment that has a dependency on it's Java, it's .NET, it's Python, it's whatever.
Yep.
You have patterns that still match certain code constructs as well, right?
Right. So we do care about the language because we need to understand the syntax of the language.
Sure.
And so there is a universal abstract syntax tree for those who kind of like to geek out about programming languages. And we're starting to move in the direction of using TreeSitter, which is what GitHub uses for their Atom code editor. And that lets us support like every language that Atom supports. But you're right, the fact that like you don't need to have compiled artifacts. I don't need to understand how like the Java bytecode is built if you ever use a tool like Spotbugs or something like that, because you're just looking at the Java source, and even it doesn't even technically have to be like valid or buildable project. We just need like one file or something, because you're just going to look for like, from java.spring. Web handler import, servlet or whatever I forget the exact, Java pattern that you'd want to look for. And then from there, you'd say, okay, cool. We're taking a request. We're getting like the user data, and then we're going to send that directly to like, exec or something, or like a file opener or a database query. And so is that safe? Well, who knows? So you can kind of look for these little simple code audits, right? When you think about just at a file level.
That's very cool, that example you had earlier there about the scale with which you're going to be able to scan things, like being able to scan 100,000 JavaScript repos at the same time. Like, I just feel like there should be diabolical music playing in the background while we describe that. Like, it sounds like a Dr. Evil kind of move, like you should be like having your hands up like this as you're telling me. No, that's very cool. That's got to be like the most, and it's got to be a problem or a solution that will really resonate with people who are scanning lots and lots of source code. Because I know that is the biggest challenge people have with static scanning, is the time frames that go into it.
Mm-hmm. Yep. And that's why we were like, most of this stuff should be, especially if you kind of don't have to depend on building the entire project, it should all be very embarrassingly parallelizable. I can get a Spot instance for an hour. It has one CPU, 2 gigs of RAM for a third of a penny. So I can do a lot of code checking in an hour for very, very cheap amounts of money. And so, yeah, having that scale is important. And I think oftentimes like the trade-off that I was unhappy seeing a lot of my AppSec friends and myself is you either say, I care about third-party dependencies and I'm going to go buy a really cool tool, let's say Sneak, or there's Dependabot or SourceClear. There's a bunch of like third-party kind of vulnerability databases, but they're typically just looking at like, does this version match the the CVE database? Or I'm going to say like, well, what's the code I can control? And I'm going to write. And it's only the companies like Google and maybe Dropbox and a few others I've talked to who actually go and like vendor all the third-party code and bring it into their kind of mono repo and actually like care about the security of their third-party libraries that get built into the final application. And I think everybody else just kind of throws their hand up and says, well, if there's some crazy JavaScript package that has a hard-coded initialization vector, someone else is going to have to fix it and find it.
Yeah, I think that's a common approach to third party that 99.99% of the industry follows, which doesn't mean it's right, but I think it's reality right now. And
it's rational because you're probably not going to get hacked unless you're like a cryptocurrency company. Someone's probably not going to take the time to like hack a third party module just to get inside your environment. I mean, I guess we saw that happen last year with JavaScript, but
yeah,
if you're just me building a startup, probably I'm safe just depending on Flask and React and whatever other third-party libraries.
But you're running SemGrep against anything you're building, so good luck. They're not going to be able to sneak any of that stuff by you. So what does the future hold then for SemGrep? Like, is there a roadmap out in years into the future? Big plans for we want to add this big cool thing? Or like, what are you thinking about the future?
We have 4 kind of key features we're adding. And I'd say, I don't know if it's like three years out, but in like say the next 2 or 3 quarters, we're working on more code equivalences. So this is letting you kind of define almost like in a plugin architecture, there might be 4 or 5 different ways to do semantically the same thing. So what I mean by that is, let's say I'm opening a file in Python. There's like the file open, there's the pathlib.open, there's with file open, I can rename things. So like, as an application security engineer, all I want to say is write one pattern that finds all file opens. And then I'd like to go kind of into this code equivalence world and say, oh, but this also matches. So I'm going to map it back into this, kind of abstraction layer. That's something I'm personally really excited about. The next thing we're working on is, I was mentioning earlier, like support for more languages. Let's go from like 5 languages we support to like 30 languages. That'll probably land in the next quarter or two. And then the third thing we're working on is integrating external type information, because this is another way you can just be so much more precise. If you take, I don't know how familiar you are with like JavaScript vulnerabilities, but for example, like the set timeout method, which is used everywhere. Everyone is trying to use like this polling architecture. You're going to hit the server every 400 milliseconds or something like that. Normally it's given a function, but if you give it a string, because JavaScript's JavaScript, it will just eval it for you. And so what I want to be able to do is write a pattern that says, find all calls to set timeout where the type is a string. And obviously type inference is a huge, hard problem. I don't want to solve that, but I do want to let the TypeScript engine or the Flow engine or some third external typer run over and say, here's what I think the type is, dump it out as a JSON file, and then I can now refine my patterns. And so for languages like JavaScript, that's easy. Python, of course, has a couple external typers, MyPy now. Sorbet exists for Ruby, and so I think that would just be a nice step up to let us write more precise things. And then fundamentally, once you have types, then it's relatively straightforward to kind of use more of a tainting engine, because you're just defining a special type, which is user data. And so the tricky thing here, though, and I think it's important to follow what the TypeScript folks did, where you end up wanting this community registry to have, here are all the places that users can manipulate data. So if you take let's say a web framework, here's the way you can change the headers, here's the way you can change the user agent. Any of these things are dirty data that you can't fundamentally trust. And then you're going to have some sanitizers that clean that up. And then you're going to have some dangerous functions, which might be exec, it might be reading right to a database without parameterized queries. And so if you can now have a list of these are the way people modify things, here are the ways that these are dangerous functions, then you can kind of glue those together and do what's classically known as taint analysis. So those are the 4 features that we're coming on: code equivalences, more language support, having external type information, and taint analysis.
So if you had to leave our audience with one kind of final thought or a key takeaway from our conversation here, well, what would that be, or what is it?
Well, my thought is just kind of zooming out a level from SemGrep is we should make the computer sweat more in doing our security. And what I mean by that is I think typically people will go through and do a pen test, or they'll look through and try to do manual inspection of code. I've certainly had it done on me, and that's great because you get the human intelligence. But what does the world look like where, as the computer's idle, as the developer is sitting there thinking, how do we run more and more analysis behind the background, saying, oh, this is going to be a bug, this is a correctness issue, it's a security problem. Or when you go submit it, let's just go run that scan really fast on every single commit. Let the computer do that work, find the hotspots, and then maybe you tell the developer directly, maybe you just send a Slack notification or open a Jira issue to the security team. And then they're going to go through and apply their intelligence. And so how do we augment and just kind of move AppSec from a human process to fully automated? I think that's just the next leap forward for security.
Yeah, that's a great line. Make the computer sweat more. I love that as a line. So Drew, thank you for taking the time to be with us today to explain SemGrep. And we look forward to following along as you do that development and talking with you some more in the future to hear how SemGrep progresses and all the good stuff that's happening there. So thank you very much.
Yeah, you can go to semgrep.dev. It's just a short redirect to our GitHub repo, start the project. There's a community Slack room. Follow us on Twitter. Very excited to be building this and doing it in the open and getting community feedback.
Why don't you tell us about SemGrep? It looks like you've got it showing us where you can find it on GitHub. Tell us a little bit about how it works and maybe show us a demo.
Certainly. So let me just, I can start by just maybe showing you a demo. The real quick thing to understand is that SemGrep is operating on code the same way that a compiler or an interpreter was. So it's turning that 1,000 lines of Python you wrote into something that is a structure that the computer understands. It's doing that both on the things you're searching for, and then also on the code you're searching, and then just doing a smart match at the kind of the tree structure, as opposed to just, oh, is this particular string or regex appearing in the file? So that's just one thing to keep in mind. As I mentioned earlier, you can go to semgrep.dev, which is just a quick redirect to our GitHub repo. go star it, follow along. We're doing our development in the open. But I'll just roll into the demo, and these are just some slides I have from the Hello Secure Conf talk I gave last week, and those are, I'm not sure you guys can put a link if people want to go see the full slides. But let's just look for a very simple kind of AppSec problem. If you think about, I'm an application security engineer responsible for securing Golang servers, and maybe I'm looking for developers who've made a pretty easy mistake to make. I actually didn't even necessarily know this until I was talking with a friend, but if you call the built-in Go HTTP listen and serve, it's just a standard web server, probably designed more for like regular web development, or maybe you're going to put it behind a proxy. But if you want to like do all the certificate stuff in the Go server, you need to call listen and serve TLS. And so this is like the simplest example, obviously one that would be relatively straightforward to search for. But here we have, a very minimal hello world kind of Go server. And so this is just setting a header and, returning. I literally pulled this from the hello world example. But what I can do with semgrep is I can almost think of it like copy and pasting my code of what I'm trying to look for. So I don't even have to think about like, how do I escape parentheses and do all that? I can just say, I want to search for this. And then because I don't necessarily know what arguments or even potentially with port the developer is serving it on, maybe they're serving it on port 5000 or something, I can just use the ellipsis operator, which is like, three periods, to just say anything goes here, right? And so, just you can run semgrep as a brew package, or you can run as a Linux binary. For the sake of this demo, it's often like I typically write patterns on our semgrep.live site, which is open, doesn't require sign-in or anything. But it's similar to like regex 101 if you've ever used a tool like that, where you're trying to kind of debug the pattern. And so, just to show you, there's like this little box here where I write the pattern, there's the code area, and then results will appear here on the right. So if I run that, it takes 0.41 seconds, and I get, a pattern here. And there's a way I can set an ID and a message, and I'll show that in my next example. But this is something that I could just write a pattern that just says, nobody should ever use this, or I want to go do an audit of my code base and find all the instances, and maybe some of them you want to whitelist because it's in a test folder or something like that. But that's just a really simple example of like copy paste using the ellipsis operator to abstract away some of the details. And let me go back. I'll open this in a new tab next time. Let's see. So the next example I was going to give you is talking about might be even more of a security relevant case. So we have this injection type attack. So this is just a minimal snippet, but imagine you have user controllable data. So in Python, that's this path parameter here gets passed to the function as file name. And then maybe I'm gonna log it or print it out, and then I'm gonna actually like send the file directly. So you could imagine someone who gets clever and they do like dot etc password, kind of right. your simple attack. So here I want to match the same thing. So if I jump over to our live site again, and I can zoom in just a second, I'm going to do exactly the same technique. So I'm going to copy this code, and I'll just go through it line by line, because obviously if I'm trying to match this, I could just use grep or something. But here again, I'll use the ellipsis operator. Say I don't know what it is, the exact route someone's using, but any sequence of characters just gets abstracted away. And then I don't know what the developer is going to call the files, so we'll just call it something like func or something. What I care about here though is file names. So I'll call that fn. I don't care about logs or prints, stuff like that. It's kind of outside the scope. And then what I actually care about here is that function it's fully qualified, so I'll do flash.send file in case someone's renamed it to something else. But what I care about is that that fn variable I defined above, that's going to flow through to here, and then I don't care about its attachment. That's all kind of noise. And so again, if I run that, it should match right there where I'd expect it to. And so that's now a pattern I can use to kind of have an invariant, which is like user controllable data should never flow to these kind of banned functions. And so that'd be an example of what we have in our registry. And then the last example I'll give you is a very simple like flash set cookie case. And so if I again open that up here, something I'm now going to introduce our like YAML syntax. So this is how we typically write rules because you want to give it a friendlier name. Again, I have a minimal example, like an insecure way of calling set cookie, something that's multi-line. And again, it was kind of a problem that'd be hard to write with regular grep. And then there's commented out code, which grep will usually match on. And here's the exact like secure set, right? So the first thing I'll do is I'll just give it a friendly name. and then I'll say, what do I not want to match? Well, I don't want to match the good thing. And so I'll say flask.response. And then I don't know what the arguments exactly are, but HTTP only. And maybe I don't know what other keyword arguments. So one thing that's subtle is it doesn't care about the order of the keywords because
yeah, I was wondering about that. I was looking at you changed the order, but it will be okay to find out or figure out. Okay, it could be in this location or that location based on
exactly.
Okay.
And it also because it fully qualifies it. So things like from Flask and report responses are, which is something I might do as a developer because I don't want to clutter my code.
Right.
It's smart enough to know that. It knows in Python that the keyword arguments are just a dictionary and that doesn't matter. So this is the case that I don't care about. Everything else I'll just say in this example I do care about. And I'll give it a friendly message. And here's where you can go through and say, anything you want. You can actually use, if we define a variable, you can put that in the message. But here I might just be like contact security because cookies are hard. Something simple like that, right? I can run that. And you'll see that it does match the two insecure cases. Set cookie here, the one with the inner function, correctly skips the comment and it realizes, oh, I don't need to match this case. And so these are just really simple patterns. We talked about our registry. I can show you a minimal page. This page is getting worked on, but we've got a bunch of different rules here. It's just pull from a Git repo. But if I did something like security, I can look at, okay, we have Python, Django security. There's 25 rules we've written just for Django in those cases. And so it's got a nice name. It's got a fully defined pattern. It's got a severity. And then there's a little bit of someone's gone through and kind of figured out all the different ways you can get a request data. And so that type of work, and maybe I'll just pop over and show rules. That's the type of work that you can say, okay, I care about this. I want to just go and scan it. I want to run it locally. If I want to run it locally, it gives you a basic Docker command. You don't even have to install anything and just scan it over a folder of code. You can use it with Brew and just pass in this config and just give it a simple URL of the YAML files or give it a Git repo. And so we have, probably for the main languages we care about, things like Python certificates, we'll have a kind of a test case, things that are bad and the different documentation. And then here's what the rule actually goes and looks like. And so someone's gone through and done a little bit of Boolean logic here to say, here's all the different ways you can kind of get a proxy manager or a connection, right? HTTP connect. And then there's some little keyword arguments, things like that. Yeah, and then what else was I going to show you? Oh, there's one other thing I can show you. So imagine I have a really simple pattern, $x equals $x. And you might be like, this is crazy. Who would ever do that? And it, we kind of look for, let's say I'm looking for if.
Right. Or even the one more common, or sometimes I see as well, if instead of the double equals as an equal. So
right, or triple equals, or yeah, exactly. But the thing I wanted to show here is this is probably a bug. Could I go run that right now in real code? So if I jump into the scan code thing, I can put in any Git repo here, or I can put in let's say Palantir, my old employer, and it will just go and grab all their different repos, and I can kind of just queue one up to scan. But if I take Apache libcloud, because this is one I've done before, it'll just instantly scan it. It takes 3 or 4 seconds. It takes 5 seconds to scan. And you'll sure enough, I think this is a real bug in one of their drivers for Cloud Sigma. So if I jump in to view that, I read through this 2,000 line function a week or two ago when I found the bug, but I think what this does is it's basically this function that gets the node and they pass in node underscore ID. But here they're going to probably return the entire list of nodes because they have node.id is equal to node.id. And they probably meant to do node underscore ID. So this is just this is not a security bug, but it is kind of fun. And it shows and so we're starting to think about how do I go run it on a real all of my repos, or go run it on 5,000 repos or things like that.
Right. Well, nice.
Yeah.
Yeah, I was, as I'm watching this, I can remember all the days I used to do a lot of code review, secure code review. And I would look for patterns just like this. And I would run all the Fortifies and the other tools like that and look for patterns and so forth. But I like, obviously the performance is fantastic, but also, um, you know, indenting and moving it to different lines and the placement of parameters and so forth. So a lot of power here. This is really promising.
Yeah, and just to give you an example here, this is like a Flake 8 plugin. I think one of the best things is you really kind of just fork it and tweak it or go modify the pattern. So
Mhm.
I was looking for some like AWS access keys. You probably can see here in a Flake 8 pattern. It took me about 100 lines of code to eventually, get down to this like node visitor and look for like these keyword arguments that are in band and make sure they were strings and other fun things like that. But like I feel like the barrier to go edit my Flake 8 config is fairly high, or I might just enable or disable some rules. I'm probably not going to go in and say, oh, actually, there's another way to set that access token using an environment variable or something. But I can quickly go do that because it's just a YAML file. I can just fork it and edit it. I just personally add them to like a YAML file to the root of all my projects, and then those just get picked up on every single commit by our action.
Okay. And so one other question I have is, noticing the number of languages, because we talked a little bit about you do need to know something about certain languages that you're looking through. You have Python, and I saw C, I believe, and Java. So are you looking for help in adding more as well at some point?
We would love help adding more languages. I think it's probably a little bit deeper in the code base. I think there's also a lot of easy first bugs that we have labeled, but just to give you a quick summary of our language support, these are the 5 that we're focusing on just because that's what our customers and our friends are using and we're using.
Mm-hmm.
And then I mentioned there's a project called TreeSitter, which is something GitHub open source for their Atom editor that just parses and colors and understands the syntax of autocomplete and whatever for your editor. We're trying to just leverage that work so we don't have to go figure out how do you parse Erlang and be an expert in every single language.
Right. Okay.
Yeah,
Great.
and then as I mentioned, like, the live site you can definitely use, but you can also just do it with Docker and Homebrew. And then, you define your pattern and you can just run it like straight here and it'll just find issues for you. Or you can pass in like this config, and just go pull our custom rules.
Which is certainly nice for, making it part of your pipeline as well.
Exactly. And, we wanted to make sure this was like easy to use and you don't have to like sign some NDA or, think about bringing in an external tool. You can just try it out now. And, there's no tracking or anything like that. Doesn't send any metrics back to us. And you can, just use your own like Git repo of your own rules if you don't want to share them. But of course, like the only way we're going to make the world more secure together is like if everyone kind of collaborates their patterns together and like, peer reviews, code reviews our work.
Very nice. Well, thank you for sharing.
Yeah, absolutely.